Hi guys, so today we're going to look at finding more zeros besides just our rational zeros. So until this point we were just finding rational zeros, which were kind of our nice pretty numbers. Today we're going to look at finding irrational zeros, like those that have square roots, and imaginary numbers, like the square root of a negative. So to start, we're going to look at just an example here that you guys have probably seen before. This is a polynomial that can factor into a difference of cubes. So I'm going to factor this using our difference of cubes formula. So that's going to be, I remember your little SCUMS acronym. So it's square the first, change the sign, multiply, which gives us 4x, and then square the last. So then what we normally would do, we would find our zero, and our zero would be x equals 4. Now that is our only real zero. It's the only place this graph actually crosses the x-axis. However, what we're going to do is we're going to find all of the zeros, which means we are also going to consider the imaginary zeros that come from the rest of this polynomial. Now that doesn't factor, which is why, again, it's going to be imaginary zeros. So we need to solve for it a different way. So there's two things you can use. You can use completing the square, or you can use the quadratic formula. I'm going to go ahead and use quadratic formula because I think more of you tend to remember that. You may have remembered it in the form of Pop Goes the Weasel. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And just pretend that's sung a little bit better, but that is your quadratic formula. A is the coefficient of the first term, b is the coefficient of the second term, c is the coefficient of your constant. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplify what's in the square root first. So that's going to be 16 minus 64, which is a negative 48. Anytime you have an I inside the square root, anytime you have a negative inside the square root, it is the same thing as an I outside of the square root. That's the easiest way to deal with imaginary numbers. Then we just need to simplify the square root of 48. So you can take out a perfect square if you're pretty good with your facts. So like a perfect square here is 16. So if 16 came out, it would leave me with a 4 on the outside, a 3 on the inside. The other way is we can make a factor tree. And we would look at our bottom numbers and take out any pairs from the bottom numbers. There are two pairs of 2s. So I would multiply those together on the outside. There's a 3 left over. So 3 stays on the inside. That's the other way to simplify. But again, if you're familiar with what your perfect squares are, that's probably an easier way to do it. Then we just need to be careful with how we simplify. Okay, we cannot just take these two values and try and simplify them. Okay, it's not going to work. We need to consider all 3 of these numbers, because when you have something added or subtracted at the top of the fraction, we need to consider both of those things. So let's go ahead, since all 3 of those numbers are divisible by 2, we can go ahead and divide them. So that gives me negative 2 plus or minus 2i root 3. Now, one thing you'll notice, we ended up with 3 total zeros. We had x equals 4, negative 2 plus 2i root 3, and negative 2 minus 2i root 3. So 3 zeros, and this was raised to the 3rd power. You may see a pattern coming up. All right, this is another one we can factor. It's a difference of squares. X squared minus 4, x squared plus 4. And then we've got another difference of squares. So it's really important to be familiar with your difference of squares. Okay. So what we're going to do now, I'm going to go ahead and set each of these factors equal to 0. So I get negative 2 as an answer. I get positive 2 as an answer. Then finally, I need to take my last factor and solve that. This one's a little easier because I don't need to use quadratic formula. It's just x squared. So when I square root it, I get the square root of negative 4, which is, or plus or minus, sorry. Always remember that plus or minus. Don't be like me and forget. Plus or minus 2i. So again, there are 4 zeros. 2 of them are real, 2 of them are imaginary, but there are 4 total zeros, and it was to the 4th degree. And finally, this last example, this is good factoring practice. Always take your GCF first. All these terms are divisible by x, so the first thing I'm going to do is I'm going to factor out my x. And then we don't need to go through our big synthetic division process because this can work with grouping. Okay, so I'm going to split it in half, and I'm going to group and take out what's common. That x is just going to stay there because that was in my original. I can take out a -4. My parentheses are the same, so that's my first factor. My x is still there. And then everything that's left over, that's my x squared -4. Then again, difference of squares. You guys are going to see these just keep coming back up. X plus 2, x minus 2. And then finally, to find my zeros, set each one equal to 0. So 0, -3, -2, and 2. So again, 4 zeros, 4th degree, which leads us to our fundamental theorem of algebra. So in the box, that is the fundamental theorem of algebra. The corollary is what we've been talking about. So every polynomial has at least one zero, but that zero could be a complex number. And in fact, if you count multiplicities, it's going to have the exact same. And remember, multiplicities are the exponents. So for example, this first one here, that's x squared. So the multiplicity is 2. So if we say 2 plus that other 0, so even though there's only 2 zeros, 0 and -7 are my zeros, but because that multiplicity is 2, because that factor is squared, that gives us 3 for my 3rd degree. So 3 of these we just worked out. So we already did the middle 3. And then the top and bottom example, and I just realized that one's cut off for you. So the top and bottom example, just if you want to see another example, especially with different multiplicities, you can there. All right. So we're going to go ahead and use that fundamental theorem of algebra, and we're going to find all the zeros of this polynomial. Okay, so first thing, there's no GCF. We could try grouping, but it's not going to work. You'd notice those parentheses would not match up. So we're going to do our P over Q process. The good thing here, not a lot of options. P is going to be the factors of 2, so only plus or minus 1 and plus or minus 2. Q is going to be the factors of the first number, so only plus or minus 1, and that's it. So P divided by Q, pretty easy this time. Just plus or minus 1, plus or minus 2. So only 4 options to choose from this time. So I'm going to go ahead and use -2. I just happen to have a hunch it may work. And again, the way we get that number, we are kind of guessing and checking here to find that value. I happen to know what it is, which is why I'm going to get it on the first try. If you don't get it on the first try, that's okay. Just do it again. All right, we know it worked because we got 0 as a remainder. So my remainder is 0. Now the remaining polynomial starts 1 degree less. So here is my remaining polynomial. Now this one, though, unfortunately is not going to factor. So since it's not going to factor, what I need to do then is solve it some other way. Again, completing the square, quadratic formula. Just to review, I'll go ahead and do this one with completing the square. So with completing the square, the way that works, we leave a blank. We move C to the other side, and we also put a blank over here. To figure out what goes in the blank, we take the middle number, divide it by 2, and square it. That gives us a perfect square trinomial. So this is x plus 1 squared, and that's 2. Then to solve this, I would just square root. So I get x plus 1 is equal to the square root of 2. And then I would subtract. And then always in front of that square root, almost did it again. Never forget that plus or minus. All right, so now we have 3 total answers here. We have -1 plus the square root of 2, -1 minus the square root of 2, and don't forget, -2. Okay, -2 was an answer because that was my value that worked back when I did synthetic division. All right, So let's try another one. Again, don't forget the methods that you've learned. This one actually can factor, because I know that there are two values that multiply to negative 27 and add to negative 6. So those two numbers are negative 9 and 3. Since this is a different term than you're used to seeing, that's okay. We just need to keep it the same. Okay, so I'm going to keep this as x to the 4th minus 9x squared plus 3x squared. Because it was x squared, it stays x squared. All right, then I look at half, take out what's common, x squared comes out. I'm left with x squared minus 9. Over on the other side, 3 comes out. I'm left with x squared minus 9. My parentheses match, so x squared minus 9. Everything that's left over. Set each one equal to 0. Well, actually, let me go ahead and finish factoring. Difference of squares again. Okay, so I get x equals negative 3, x equals 3. And then I got to solve this one. Square root it. And there are my 4 answers. So positive I times the square root of 3, negative I times the square root of 3, and negative 3. Okay, so now what we're going to do is we're going to go backwards. Okay, so we are going to look at some other theorems, okay, the irrational root theorem and the complex conjugate root theorem. Basically what these are telling us, okay, something you guys have probably already seen, like whenever we did quadratic formula, because it's plus or minus that square root, those irrational zeros are going to come in pairs. So for example, if 3 minus the square root of 7 is a 0, then 3 plus the square root of 7 will also be a 0. Okay, those are going to come in pairs. Also coming in pairs are imaginary numbers. Okay, so our imaginary numbers, so if I have 3 plus 2i as a 0, 3 minus 2i will be a 0. Okay? So let's look at a couple. Oh, before we do that, there had been some questions on some of the terminology. This just may help you remember what some of those words mean. So basically, the big outside box are complex numbers. That's everything. Imaginary numbers are kind of over there on their own. In that big red circle are all of the real numbers. And then over on the side is those irrational numbers. Irrational numbers are the ones we're talking about with the square roots usually, like the square root of 3, 2 minus the square root of 5. A lot of those ugly answers you get from the quadratic formula are irrational. Rational are kind of our pretty values. They can be written as a fraction. Okay, it's like a negative 5.37. Okay, they can all be written as a fraction. And then those sets just get smaller and smaller. The smallest is natural numbers. Those have to be positive and they have to be whole numbers. 0 isn't really included there, which is why whole is kind of its own category. And then integers can be plus or minus. You don't have to know that for in here, but it may just be helpful for you just to know that terminology because it'll keep coming up in your math classes. All right, so again, we're going to work backwards. So given this information, we're going to write our polynomial. So what this is going to do to us is it's going to give us some ugly foiling, but for the most part, it's not too bad. So to start, if 3 is a 0, then x minus 3 is a factor. If the multiplicity is 2, that factor is going to be squared. Then if root 7 is a factor, we also know that negative root 7 is also a factor. So I can write this as x minus root 7, or I could write this as x plus root 7 because it's minus negative. So both of those are options. What's nice about this, it makes it really easy to FOIL because it's a difference of squares, which means those middle terms there are going to cancel each other out, so we don't need to worry about them. So I just need to do x times x, which is x squared, minus root 7 times root 7, which is minus 7. That process there, it's multiplying by the conjugate is also what we're doing. That terminology you'll probably see going forward as well. It's a strategy that you'll use. And remember, x minus 3 squared is x minus 3 times x minus 3. So FOIL that out and you get x squared minus 6x plus 9. And then from here, again, just make sure you multiply everything times everything. So I get x to the 4th minus 7x squared minus 6x to the 3rd plus 42x plus 9x squared minus 63. Combine any like terms you can combine. So that gives me x to the 4th minus 6x cubed plus 2x squared. Let's see, plus 42x and minus 63. And it's, again, it's going to be some ugly multiplication, but if you can set up that first step, it's going to make a big difference. All right, so let's try this one. Same idea, but imaginary numbers. Again, if 3i is a 0, negative 3i is a 0. So x minus 2 is a factor. X plus 3i, well, let me do x minus 3i first. It doesn't matter, but I want to make sure they match up with the zeros I just wrote above there. X plus 3i. And again, this is their conjugates, so those middle terms are going to cancel. So all I have to do is x squared minus 9i squared. And what we have to remember from that previous unit is what I squared is. So I squared is the same thing as negative 1. So negative 9i squared becomes plus 9. And then this one's a little easier to FOIL. Okay, make sure you multiply everything times everything. X to the 3rd minus 2x squared plus 9x minus 18. All right, the last ones we're going to look at are when we get kind of the messy algebra. So there's two different ways that you can work this out. One of them shows some more steps, but may make more sense algebraically about what you're doing. The other way I'm going to show you, I think, is a little bit easier to get your value. Okay, so let's start from the top. If 5 is a 0, then x minus 5 is a factor. Okay, now it gets a little messy when we have a root that looks like this. Okay, so 2 minus root 3 is a 0, but also 2 plus root 3 is a 0. So I could write that in a condensed form. I'm going to write it as 2 plus or minus root 3. That's how you guys are used to seeing it with quadratic formula. Okay, so what I'm going to do, I know that x is equal to 2 plus or minus root 3. So what I'm going to do here is I'm going to work backwards. Okay, so I am going to basically do the opposite process of what I did with like completing the square and the square root method. So I'm going to subtract 2. Then I'm going to square both sides. So that gives me x squared minus 4x plus 4. Shortcut here that you may have heard is the square double square. So it's square, you multiply and double, and you square the last. So square double square. And then if I square the square root of 3, it's just 3. And then I want this whole thing to equal 0. So now this is my polynomial. Okay, and this is a little bit easier than if I were to go through and work this algebraically a different way. So what I'm going to do is I'm just going to draw a little box here, because this is kind of our side scratch work. But I'm going to take that answer and plug it in here. Now all I have to do is the messy foiling. Okay, so just be careful again, get everything times everything. All right, then plus 20x, and then minus 5. Sorry, I'm running out of space here. Combine your like terms, so I get x cubed minus 9x squared plus 21x minus 5. All right, last one, same concept, okay? So same concept, but now we have imaginary numbers. So again, we know our factors are going to be x minus 1 and x plus 2. If 3 plus I isn't a 0, 3 minus I is a 0. So my two zeros are 3 plus or minus I. So again, I'm going to do the same process as last time. Over here on the side, I'm going to do x equals 3 plus or minus I. And I'm going to work backwards. So I'm going to subtract. I'm going to square it. So that gives me x squared minus 6x plus 9, so square, double, and square. And then I squared, it doesn't matter if it's plus or minus, a negative I, because it's inside the parentheses, okay? It's just going to be I squared, and I squared is negative 1. Add that one over, and that is my polynomial that I'm going to be using. Let me just continue my little box. So we're going to take that, plug it in, and I get x squared minus 6x plus 10. You can multiply this in any order. I think it's a little bit easier if you do those two binomials first, just because those are pretty fast usually. So x squared plus x minus 2. And then we just have the messy algebra here to get these all multiplied together. So x squared times x squared. Okay, and then we go to middle, so x cubed minus 6x squared plus 10x. And then I got my minus 2. So minus 2x squared plus 12x minus 20. And then we just combine all of our like terms. So x to the fourth is on its own. Minus 6x cubed plus x cubed should give me minus 5x cubed. I've got positive 10x squared minus 6x squared minus 2x squared leaves me with minus 2x squared plus 2x squared. Sorry about that. Then I've got plus 10x plus 12x gives me 22x. And then finally minus 20. All right. So again, some messy algebra, but a process that's pretty similar to what you guys have been seeing. A couple reminders: your imaginaries and your square roots come in pairs, plus or minus. I squared is a negative 1. And then don't forget your quadratic formula. All right, well, that is it, guys. And again, just be sure to come see me if you guys have questions.